Hello everybody, this is the second lecture of statistics in Azure GSIS. This is about syllabus. As you know, my name is Jang Byung-yeon. This is English name. Byung-yeon Chang is English name. My office is Dasan Hall, 420. Email is here. So if you have any question, then you can use my email address. Or if you want to meet me, then you can stop by this office. Okay. This is my grading policy. Class participation is 10 plus alpha. If you are very good, then I'm going to give you more points. And this is attendance policy. 2 point subtraction for each absence in final total score. It's huge, so do not miss the class. This is the exception. If you let me know the reason of your absence in advance, then I'm not going to subtract. But your explanation should be reasonable. Kids 20%, midterm 30%, final 40%, then 100, right? But this is a tentative policy. So as we go in on our class, then it's possible to change it. Okay. Last time we talked about descriptive statistics. Descriptive statistics deals with the method of organizing, summarizing, and presenting data in a convenient and informative way. One form of descriptive statistics uses graphical technique, which allows statistics practitioners to present data in a way that make it easy for readers to extract useful information. Another form of descriptive statistics uses a numerical technique to summarize data. The mean, median, range, variance, standard deviation, those are very often and useful descriptive statistics. Let's see another example, election example. When an election for political office takes place, the television network cancels regular programming and instead provide election coverage. When the ballots are counted, the results are reported. However, for important offices such as president or senator in large states, the network actively compete to see which will be the first to predict the winner. This is done through exit polls, wherein a random sample of votes who exit the polling booth is asked for whom they voted. From the data sample proportion of votes supporting the candidate is computed. A statistical technique is applied to determine whether there is enough evidence to infer that the leading candidate will garner enough votes to win. The exit poll result from the state of Florida during the 2000 election were recorded. Only the votes of the Republican candidate George W. Bush and Democrat Albert Gore. Suppose that the result, 765 people who voted for either Bush or Gore, were stored on a file on disk. The network analyst would like to know whether they can conclude that George W. Bush will win the state of Florida. This example describes a very common application of statistical inference. The population the television network wanted to make inferences about is the approximately 5 million Floridans who voted for Bush or Gore for president. The sample consisted of 765 people randomly selected by the polling company who voted for either of two main candidates. The characteristic of a population that we would like to know is the proportion of the total electoral rate that voted for Bush. Specifically, we would like to know whether more than 50% of the electoral rate voted for Bush, counting only those who voted for either Republican or Democrat candidate. Because we will not ask every one of the 5 million actual voters for whom they voted. We cannot predict outcome with 100% certainty. A sample that is only a small fraction of the size of the population can lead to correct inferences only a certain percentage of the time. You'll find that statistics practitioners can control that fraction and usually set it between 90% and 99%. To understand previous examples, I'm going to introduce some statistical concepts. It's a very important concept. First one is a population, second is a sample. If you are familiar with the statistics, you already know this concept, but some of you guys are not familiar with the statistics. So I'm going to introduce these two concepts. First one is population. Population is the group of all items of interest to statistic practice. Is a population is the group of all items of interest to statistics practice. Frequently very large, sometimes infinite. In previous example, all 5 million Florida votes are population. All 5 million Florida votes are population. Sample is a set of data drawn from the population. So we can draw population from what? We can draw sample from population. Population is all 5 million Florida votes. Potentially very large, but less than population. A sample of 765 votes except polled on election day. So these are samples. So from the population, we can draw sample. Next concepts parameter and statistic. Parameter is a descriptive measure of population. Parameter is a descriptive measure of population. Statistic, not statistics. Statistics is display. So as you can see, these are population, sample, parameter, statistic, their relationship. From population, it is related, the population is related to parameter. Actually, parameter is going to describe a population. Statistic is going to describe the sample. And subset of population is a sample. So population have parameters, samples have statistics. As we know, descriptive statistics are methods of organizing, summarizing, and presenting data in a convenient and informative way. These methods include graphical techniques and numerical techniques. The actual method used depends on what information we would like to extract. Are you interested in measure of central location and or measures of variability? That is dispersion. Now I'm going to introduce inferential statistics. Descriptive statistics describe the data set that's being analyzed but doesn't allow us to draw any conclusion or make any inferences about the data. Hence, we need another branch of statistics. That's inferential statistics. Inferential statistics is also a set of method, but it is used to draw conclusions or inferences about characteristics of a population based on data from sample. As you can see, statistical inference is a process of making estimate, prediction, decision about the population based on sample. As you can see here, sample is a subset of a population. Okay, so based on sample, we calculate statistic, and then we estimate the parameter based on statistic. Then we can see based on parameter we explain or we know characteristic of a population. So what can we infer about population's parameter based on samples statistic? This is a process of making decision. Okay, so this is called what? Statistical inference. Statistical inference. We use statistic to make inferences about parameters. Therefore, we can make an estimate, prediction, or decision about populations based on sample data. Thus, we can apply what we know about sample to the larger population from which it was drawn. Since larger population make investigation each member impractical and expensive, we need statistical inference. Statistical inference is easier and cheap to take a sample and make estimate about the population from the sample. So that's why we need statistical inference. However, as you can see, such conclusions and estimates are not always going to be correct. For this reason, we build into statistical inference measurable reliability, that is, confidence interval and significance level. Confidence level and significance level. Up to now, I am explaining what is statistic, descriptive statistic, inference statistic, population parameter, sample statistic. You should understand what is the meaning of this, and based on this, I'm going to show you how to analyze data. Okay, so but before I'm going to move to next explanation, you should please understand what is the meaning of this.